As well as malloc, there's another function called calloc that's often used when allocating memory. Just like malloc, the calloc function allocates memory, but it also performs one additional step. It clears the memory. In other words, it initializes the memory with nulls. Uninitialized memory contains unknown data, junk, which you could accidentally try to use in your program. If you allocate memory with calloc, a series of nulls will be written into that memory, until, of course, you specifically write some other data there. If you are careful always to initialize allocated memory, then by all means use malloc. The calloc function performs exactly the same function as malloc, but in addition, it ensures that the allocated memory is initialized, and that allows you to test the allocated memory, if required, so that you know whether or not any specific data, the data that you intend it for, has yet been written into that memory. The only other difference to bear in mind is the syntax. Malloc takes a single argument, which is the size in bytes, of the memory required to hold all the data you want to store. Calloc takes two arguments, the number of elements in the array and the size of each element. You can calculate the size using the size of operator. Incidentally, you can also use size of with malloc if you need. For example, I could rewrite this line here, which I've just got 6 as the single parameter to malloc. I could rewrite it by calculating the size of the type, which is here char, multiplied by size of char. That's entirely valid. But since a simple char is just 1 byte in size, this isn't necessary here, but with other data types, such as doubles, it would be needed. So let me run my code to see how it works. And there's the results. So here I just allocate memory with malloc, but the memory is uninitialized, so when my for loop iterates through it, I just print out whatever random values happen to be there. As you can see, all sorts of unpredictable numbers are returned. But when I do the same thing with calloc, the memory, that is the character array to which my char pointer points, well, that's been initialized with nulls. And similarly, the memory pointed to by my int pointer p, here calloc 6, size of int, well, that too has been initialized with nulls. Let me just close that. Bear in mind that both malloc and calloc return a generic pointer, a pointer to void, or a null pointer if the allocation of memory fails. It's worth saying at this point what a null pointer actually is. It's nothing more nor less than a pointer whose value is 0. In other words, whereas other pointers store a number greater than 0, which is treated as an actual address in memory, by convention, a pointer with the value 0 is considered to be one that does not point to a valid address, and we call a pointer with 0 value a null pointer. A pointer that points to nothing, and we can test for a null pointer in our own code. You can see an example here that I used in an earlier program where I test if s equals null.